Well, class, so we're going to go over the final exam for semester 1. So what we're looking at here is a projectile motion type question. So we know this is, by the way, fairly accurate information coming off of the Olympics a couple years ago. So we have this American snowboarder. We know her mass, and we want a force diagram for Jamie here. So here's Jamie. We can put her at point A here. So it's going to look like this. Here's Jamie. Okay. So the important things I'm looking for here is force of gravity goes that way. Force of friction opposes motion. And force normal is perpendicular to the surface. Okay. So that is the first one. All right, next up, calculate the potential energy lost from the starting point to point B. Okay, so gave you a huge hint here. All right, and we can just do okay, and then what we see is, again, we have her mass. Okay, so everything's in the correct units. So we have 55 kilograms times 9.8 times 13 meters. And I have that written down somewhere. Okay, so that gets us through the first page. So the next page, we're looking at the coefficient of friction between the board and the snow. So there's a few points that have to happen here. If we look back at our diagram, that's when things are going to start becoming important here. Okay, so we have the force of gravity. And Tesh should try to do this on a second page so that we could split this up here. So if we have the force of gravity this way, okay, then we're going to have force normal going perpendicular to the surface, or this is going to be our force in the y, okay? And then we have our force in the x, okay? And this is still 35 degrees, okay? Remember, this is important because this is going to be equal and opposite to the force of normal, right? Force gravity is going to be acting this way. Force normal is going to be opposite of that, okay? But the magnitude, the number is going to be the same. So if we can find our force of the y, that is going to be our force of gravity times cosine of 35 degrees, okay? Which I should have here. So that should equal 44 or 1.5 newtons. And then that was our force normal. And then force of friction equals mu force normal. Okay. And that is going to be our mu, which we should go all the way to the beginning. When did I say this? 0.03. Okay. Times 1.5. And that is 13.24 newtons. Okay. So that takes us through the next one. Find the work done by friction from starting point to B. Now this is where you really have to pay attention because work equals force times distance in the same direction. We found the force going this way, or more importantly, the force was going this way. Okay, so we need to find the distance in that direction as well. Okay, so if we have our 35 degrees, we have our 13. Okay, so remember sine of theta equals opposite over hypotenuse. Okay, now I'm asking for your hypotenuse. Okay, so we're going to work that backwards. We know those points. So let's put that in over here. So we have sine of 35 equals 13 meters over your hypotenuse, which is really your distance. Okay, and when we solve for that, we should get that distance. Okay, and now we can multiply it by that force. So our force was 13.24 newtons, and our distance was 22.4 meters, and that should give us, excuse me, 22.6. That should give us something very close to 300 joules. Okay, all right. Next up, what was her maximum kinetic energy at point B? Okay, well, we know there were 7,000 joules, and we know she lost 300 joules. So we can do this fairly quickly. So we can say the energy at the start can equal the energy at B. Remember, A was halfway in between, so I'm kind of going back past A. Okay, so the energy at the start was our 7,007 joules. Okay, we could look at E start, the kinetic energy start plus the potential energy of the start plus, well, there's no springs, so that would be that. It's going to equal our kinetic energy plus our potential energy, but we also lost some work due to friction. So our work equals change in energy. So if we look at how much did this change, that will tell us the work done. So we know it started with this. We know it changed that much. So we just have to subtract out 300 joules. Okay, and that's going to get us our 6. Okay, so that will be the remaining energy for Jamie. Okay, I mentioned this is all for Jamie because now we have the gold medal run. Okay, this is a different person going at different speed with a different mass. Okay, so we can, I did that because I didn't want any mistakes that happened here to influence your final answer. Okay, because this is going to become a longer question. Okay, so if we look at this, now we can just focus down on a different person here. So now we have Anna right here at 35 degrees again, and she is going 14 meters per second at that angle. Okay, and it does all sorts of things, but the important point is when she lands, that is 8 meters below. Okay, so she lands again somewhere over here, let's say. Okay, and we want to know distance. Okay, so by the way, you'll notice some people worked on multiple pieces of paper. That's great to use scrap paper. Normally the AP exam will give you some blank pages as well. You can always label them and attach them. Okay, so what we're going to do is solve for time. So, well, first we need to, let's find our velocity in the y and our velocity in the x. And so velocity in the y is going to be 14 times the sine of 35. And velocity of x is going to be 14 times the cosine of 35. Okay, so if we're still looking at these, when I plugged in those numbers, my velocity in the y was 8.03, and my velocity in the x is 11.46 meters per second. So next up, we have, again, operating just in our y's. Okay, so we're going to have 8 meters plus 8 meters per second times t plus 1/2 negative 9.8 t squared. Okay, so she started 8 meters high. She was going up at 8 meters per second. So this is up, this is up, this is down. So positive, positive, negative, so I'm keeping track of here. Okay, I plug that into the quadratic calculator. Okay, and I get my time was 2.33 seconds. Right, and then I can come over here. How far did she fly in the x direction? So I can do a similar formula, but it's going to simplify down to, okay, and so we have 11.46 times 2.33 seconds. And what does that give us? And that gives us 26.7 meters. Okay, all right, and that stops part 1, so we'll pick up with a new video here in a minute.